Okay, so today we're going to look at multiplying a little bit more, and tomorrow we're going to do division. So on Friday, you guys, without me, did a great job with multiplying a monomial through a polynomial. And today we're going to multiply a polynomial times a polynomial. So we're going to start with two binomials. Okay.
And your microphone might not be on. Yeah, maybe.
Okay, now I've got it. All right. So we're going to start off with 2x plus 1 times 3x plus 4. And so basically we're just going to distribute here. But when we look at it, it's a binomial times a binomial, so we're going to have to distribute both terms in that leading binomial. So the 2x has to be distributed through, and we distribute the 2x times the 3x, that makes 6x squared, and the 2x times the positive 4 makes positive 8x. And now we're going to distribute this 1. And so 1 times 3x is 3x. And 1 times 4 is 4. And in this case, these two terms are like terms, so we'd have to combine them. So my result is a quadratic trinomial.
Why would it be 4 2
Because it's just 1 times 4.
So more than 3 is a polynomial.
More than 3 is a polynomial. So this one is a quadratic trinomial. Now, they have this cute little, what do you call it when you have letters that help you remember? Acronym. Good. They have an acronym for multiplying a binomial times a binomial. You can learn it if you want. You don't have to if you don't, because it's just distributing. But the acronym is called FOIL, and it stands for first, because the first thing you can do is multiply your first terms in each binomial. 2x times the 3x is 6x squared. Then you'd multiply your outer terms, or outside terms. So if we did outside times outside, 2x times 4 is 8x. Then you would do those inside terms, or inner, since I said outer, let's say inner. So the inside here times the inside here, the ones that are inside, 1 times the 3x is 3x. And then the last terms in each. The last term in this binomial times the last term in that binomial gives us that. So if you're ever talking to a math teacher and they say we're going to use FOIL, that's what they're talking about. Multiply your first terms, your outer terms, your inner terms, and your last terms. And then your final step is to always look at your result and see if you have any like terms and combine those. Okay, you try. Three n plus 2 times 5n minus 1. Not sure what to do. Stop your mom, walk away. We'll distribute the 3n through, and when we do, we get 15n squared minus 3n, and then distribute the 2 through, so we get 10n minus 2. And when we combine like terms, we get 15n squared plus 7n minus 2. Any questions? Okay. So now let's do a binomial times a trinomial. So let's do 3x plus 2 and 4x squared minus x plus 3. Okay, exact same thing. We're still going to distribute. I always start with a polynomial that has the least number of terms, so I would start by taking the 3x, distribute it through the trinomial, and then the 2 and distribute it through the trinomial. So when we distribute that 3x through, we get 3x times 4x squared makes 12x to the third. And then 3x times a negative x makes negative 3x squared. And then 3x times 3 gives us 9x. Now we have to distribute this positive 2 through. So positive 2 times 4x squared is a positive 8x squared. A positive 2 times a negative x is a negative 2x. And a positive 2 times a positive 3 is a positive 6. And then we look at our result, and if we have any like terms, at this point we need to combine those. So we do. We have the negative 3x squared and the positive 8x squared are like terms. And then we have the 9x minus the 2x. So my result is 12x cubed plus 5x squared plus 7x plus 6, which is a cubic polynomial. Okay, so I'm going to give you one to try, and keep in mind what I said. I always take the polynomial with the fewest terms and distribute it through the other. Okay, so 2x squared plus xy minus y times y squared plus 3x.
What'd you get? 2x squared y squared plus xy cubed minus y cubed. Okay. Plus 6x cubed plus 4x squared. 4x? Just 4x squared. 4x. All the quarters. Alphabet times x.
Okay, so I'm going to do it this way. I'm going to distribute the y squared all the way through. And then I'm going to distribute the 3x all the way through. Now, because multiplication, the order that I choose to do this multiplication does not matter. If I distributed this through those two, and then this one through those two, and then this one through those two, I'd still get the same result as long as I multiplied correctly. So, when I do the y squared times the 2x, I get 2x squared y squared. When I do the y squared times the xy, I get xy cubed. Y squared times negative y is negative y cubed. 3x times 2x squared is positive 6x cubed. 3x times xy is positive 3x squared y. And 3x times negative y is negative 3xy. Now, we're looking at this big mess going, okay, the first two terms have a degree of 4, and the next two terms have a degree, well, the next three terms have a degree of 3, and the last term has a degree of 2. So we're kind of going from highest degree to lowest degree. When we get to a problem like this, where we have multiple variables and we have a lot of degrees that are the same, there's not a whole lot we can do as far as standard form goes. I'm in order from greatest degree down to lowest degree, but I've got multiple variables here. So at this point, I'm not counting off. The standard form really matters if everything's in terms of one variable. Then I always want it going from highest to lowest. Or if it goes down pretty and back up pretty. If you just have two variables in it and it has that nice A can go from second degree down to the 0 while the B goes from the 0 up to the second. That we could write nicely. But this one, there's not a real pretty way to do it. So, as long as you distribute correctly and you have your answer written there, we're good.
So would that be the answer?
Is there anything to combine? Let's take a look.
I don't understand anything.
Is there any like terms here?
No.
No! That is it. That is all we can do with this. Okay? Alright. Now, let's take a look at something like this. X minus 4 squared. Well, what does that mean? It means x minus 4 times x minus 4, doesn't it? Okay? So when we have one like this,
I did one like that on video today.
we get x squared. Yes, I noticed you were doing those. Minus 4x. And I think what happened was they wrote the wrong page number on the board to start with, and then they corrected it at the end of class. And some of you saw that correction, and some of you did.
Yeah.
Okay? All right, you try.
Do you have to write it out, like if it has like a 6 instead of a 3? Do you have to write out the thing 6 times? Or is there like a simpler way to do this?
That's what we're about to investigate.
Oh, good.
But how's it 4x?
Ever.
Multiply this times this times that, and then that times that, and then that times that.
Problem with this is everyone gets completely different answers, and you don't know who's right and who's wrong until the very end.
Okay. I'm going to go straight to the answer. Is that what you got?
Yes.
Okay.
Yeah.
Okay. I'm going to go straight to the answer. I'll check and see if I did it right.
No, you did it wrong.
Okay.
Can I do it so fast?
Yeah, you're about to see how I'm doing it so fast. So there obviously is some kind of pattern to this. Or I wouldn't be able to go straight from this to the answer like boom. That's not even written on my sheet. I wasn't even cheating. It's not on my notes or anything. So, what am I doing to get there? Let me show you. Let's look at the pattern that raising a binomial to a power gives us. Okay, so here we go. Let's say we had, oh, I need to write this over to the left. A plus B, and we raised it to the 0. Very good, because anything raised to the 0 power is 1. Okay, now let's do A plus B, and raise it to the first. What do we get? A plus B. So what's the coefficient of this one? 1. And what's the coefficient of this one? 1. Okay. Alright, now I'm going to do A plus B squared, which you do A plus B times A plus B is A squared plus AB plus AB plus B squared, which is square the first one, double the product of the two, and square the last one. You see that this is the form of any binomial being squared. If we square that first term, double the product of the two terms, and square the last term. Let's go back real quick. Is this the square of the first term? The product of these two is 10x. Is that 10x double?
Yeah.
And this last one is the square of the last. Square of the first. The product of this is negative 18x. Is that negative 18x double? Yes. And you square the last one. Okay? You're going to do this one with no work. Okay? So because of the pattern we just showed, we would square the first one, double the product, and square the last one. So we get 9x squared, double 15x, and it's positive. So it's positive 30x, and square the last one. Okay, now this is only going to work when we're expanding a binomial. And that little pattern only works for the second power. Whoops, sorry. I'm getting flippy and crazy. So, let's look at the coefficients here. The coefficient of this first one is 1. The coefficient of my middle term is 2. And the coefficient of my last one is 1. Okay? Now I'm going to do it to the third power. Now, isn't the third power like the second power times the first power? Wouldn't that give us a third? Okay, I'm not going to show you all the work, but you're just going to have to trust me on some of this. So, I will show you work. This makes a cubed plus 2a squared b plus ab squared plus a squared b plus 2ab squared plus b cubed, which simplifies to a cubed plus 3a squared b plus 3ab squared plus b cubed. Let's look at the coefficients. What are they? 1, 3, 3, 1. 1, 3, 3, 1. Do you see my triangle I'm forming up here? This is Pascal's triangle. And you already, what's the next line?
It would be 1, 4, 4.
1, 4. What goes right here?
5.
No.
4, 6.
6.
1, 4, 6, 4, 1.
Okay.
But no.
Okay, Luke, why is that
You got them.
Because
it? You do. What's the next line? 1, 5, 10, 10, 5, 1.
That's so confusing. I'm not.
Okay, so what they saw was they noticed a pattern. To get this term, you add the 2 before it. to get this one, add those two, add those two. Add those two, add those two, add those two. Add those two, add those two, add those two. Do you see how the 1 and 4 makes the 5? The 4 and the 6 makes the 10. The 6 and the 4 makes the 10. The 4 and the 1 make the 5. Okay? So this is, yes. So here we are expanding a binomial. So what would the fourth power look like? Well, we know it goes 1, 4, 6, 4, 1. And you start with the first one to the highest, the second one to the lowest. Down 1. The first term to the third, the second one to the first. Down 1. The first one, down 1, the second one, up 1. The first one, down 1, the second one, up 1. The first one, down 1, oops, 0. The second one, up 1.
Slow motion, please.
Yes.
Is this recorded?
Yes.
Good.
Yes. Okay, so this makes 1a to the 4th, 4a cubed b,
I didn't get her.
6a squared b squared, 4ab cubed, and then b to the 4th. Okay, so our fifth power,
Go, please stop.
we'll stop after 5.
I'm
Oh,
Okay,
I-
1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Okay, so the first term of our binomial gets raised to the fifth power.
Okay.
And the second term to the 0, so that it adds up to 5. Then we take that first term and drop it down 1. So now the first term gets raised to the fourth power, and the second term gets raised to the first. You see it adds up to 5. Then you take the first term and drop it down 1, and the second term and move it up 1. Still adds up to 5. The first one drops it down 1, the second one moves up 1. The first one drops down 1, the second term moves up 1. And the second term moves up 1.
Okay,
It
that,
makes sense now, but I still.
Okay.
that always makes sense.
Yes, there.
How would you do this with just like a regular number, no variable? Like if it was a plus 5.
No bird, no baby.
That's what I'm about to do. Okay? Okay. So, because this works so nicely, this is the first 0 power, first power, second power, third power, fourth degree, fifth. And do you see how to build the triangle? Okay, so if we did 2x minus 1 to the 4th, sure, we could write 2x minus 1 out 4 different times and distribute, and then distribute, and then add like terms, and then finally get to the answer. Or we could go, okay, fourth power. This is the fourth degree. I know this because the second number is a 4. This is a third degree. This is squared. This is fifth power. Not degree, power. So what I would do, this is the fourth power. So I know my pattern looks like this. 1, 4, 6, 4, 1. The first term, the second term. So here the first term gets raised to the 4th. The second term gets raised to the 0. The first term gets raised to the 3rd. The second term gets raised to the 1st. The first term, let me get myself more room. The first term gets squared. The second term is squared. The first term is now down to the first power. The second term is now up to the 3rd. And the first term goes to the 0 power. And the second term goes to the 4th power.
I think so.
10 to the 4th is 16, so this is 16x to the 4th times 1 And then this becomes 4 times 8 cubed, and 1 to the first is negative 1. So this becomes negative 32 x to the third. This becomes 6 times 4x squared times positive 1. So this is positive 24x squared. This is 4 times 2x times negative 1.
Oh my god.
So it's negative 8x. Okay, thanks. Okay. Alright, so this becomes negative 8x. And this becomes positive 1. Okay, your homework is on your calendar. There's not a ton of expanding. The multiplying is the main dilly. Alright, make sure you get your cell phones. I'm going to post this video. Yes, sir.
Did you go over